Good morning, and today we're going to look at how to use the discriminant for higher level quadratics. So basically we can use the discriminant to find unknown coefficients in a quadratic equation. Okay, now here's just a reminder. If the discriminant, which is b squared minus 4ac, is greater than 0, then we have real and distinct roots, okay, or real and unequal roots. If b squared minus 4ac is equal to 0, then the roots are real and equal. That means that we have one root. If the discriminant is less than 0, then the roots are not real, and that means it does not cross, the parabola does not cross the x-axis. So this is what I mean by this. So here we have an unknown coefficient. So we have a number in front of the x squared, we have a number in front of the x, but that's a q at the end there. And that's the part we're going to have to find. So we're asked to find q if the quadratic being equal to 0 has real roots. So it's the real roots part that you use to make up your discriminant. Now, we know that if we have real roots, then that's actually two of the things. Roots are real and equal, roots are real and unequal. So we have two conditions when the roots are real. Roots are real and equal. Roots are real and unequal, so that means that the discriminant is both equal to 0 for roots and real and equal, and unequal greater than 0. So we put those two together, and that's how we can make up that the discriminant is greater than or equal to 0, because we've merged two together. We identify our coefficients. We have A as 6, B is 12, and the C is the letter Q. So we put that into the discriminant, making it equal, greater than or equal to 0 to begin with. And we'll then use that to find what the letter Q is. So we substitute the numbers in. B squared minus 4ac is 12 squared minus 4 times 6 times Q. And we know, because we're told that the roots are real, that we can make it greater than or equal to 0. So it's important that you start with that fact to begin with. We start to put this together. We've got a 144 from the 12 squared, minus 4 times 6 is minus 24, and then we want to rearrange it. Now we can take the 44 over to the right hand side, which makes it a minus 44. And then we're about to now take the negative 24 over to the right hand side and make it a divide by negative 24. Now remember from National 5, when you have to divide by a negative, when you're dealing with an inequality, when you divide by a negative, there's one thing you have to remember. You turn the inequality sign around, because you are changing the balance of the left-hand side and the right-hand side of the inequality by doing so. So see how we have taken the negative 24 over to the right-hand side to make it a divide, but we've also turned the inequality sign around. Oops, and you can see that just right there. Okay. So the final answer is Q is less than or equal to positive 6. Negative 144 divided by negative 24 is positive 6. So we've now found the value of Q in terms of the inequality. So Q is less than or equal to 6. So the equation has real roots when Q is less than or equal to 6. And that's how you would answer that question. Okay. Here we have a more complicated one, but we still have letters as coefficients, but we can see that we have the letter P written twice, which makes it a bit more tricky. So find P, given that x squared plus, and the coefficient of x is P minus 3 collectively put together, plus P is equal to 0. And this time we're told it has non-real roots. So what do we know about the discriminant for non-real roots? We know that the discriminant is less than 0. So we set up the discriminant and initially make it less than 0. The discriminant will be less than 0 because it has non-real roots. So we have A is equal to 1, B is equal to P minus 3, and C is equal to the letter P. Put that into the discriminant, but making it less than 0 to begin with. Okay, so we're going to square out this bracket. Remember how you square a bracket quickly? You square the first term, then 2 times the first times the second, and then you square the last term. So you square the first term, get P squared, then multiply them both together and double them. That's 2 times the first times the second. So multiply them together and double them, minus 6P, and then square the last, which is plus 9, and then minus 4P. Let's put our p's together. We've got a minus 10p in the middle there. And now we have a quadratic inequality to solve. So remember we did this earlier on, and we have to use a very specific method to solve a quadratic inequality. We have to use a sketch of the quadratic equation to be able to help us see how to solve it. So basically for this quadratic inequality, we now want to look to see where is the quadratic less than 0. So we start to solve it, we start to factorise it, okay, and then we would look at the equation which is p squared minus 10p plus 9, we're going to make that equal to 0, okay, so we're going to make it equal to 0, so the two brackets that we have, bring that over to the side with your working at the side, make your brackets equal to 0, so that tells us that p is equal to 9 and p is equal to 1. Now on a sketch, we're going to mark on the x-axis the 1 and the 9 and then look to see what the shape of the graph is going to be. Now if it's a positive p squared, that means it's going to be a happy graph, which is a U shape. There we are. Okay, so you don't even need the y-axis on your sketch, just the x-axis and the shape of the graph. Put the shape of the graph in. And then remember what we're trying to solve here. We're trying to solve where is the graph less than 0. So we can see that the graph is less than 0 here, between 1 and 9. That's where it's below the x-axis. Remember how we solve a quadratic inequality. So it is less than 0 between 1 and 9. The equation has non-real roots when p is between 1 and 9, physically in between 1 and 9. And remember, your inequality signs go in the same direction when your letter's in the middle. And you can pick one of them to decide the direction. P would be less than 9, so that means that 1 would be less than p. Both inequalities go in the same direction. Okay, now you can't go from there to there without having a graph to actually physically look to see that in this case it's below the x-axis between the two numbers. And obviously the shape of the graph would be important because it would be completely the other way around if it was an upside down U-shaped parabola. Okay, so we're now on to exercise 8i, and we're going to do the selection of questions as shown. As always, ask your teacher if you need any help. Take care and good luck.